The last section that I want to cover in this chapter is going to be critical thinking to evaluate scientific claims. I feel like this is an especially important topic to talk about during this time of the COVID-19 crisis. There's so much information and misinformation out there that I think it's very important that we discuss critical thinking in order to evaluate scientific claims that are being made. So when you're reading or hearing about certain scientific claims, it's essential that you're thinking critically and you're evaluating the information that you're hearing. And you can do this by just asking yourself a few simple questions like, is this information consistent with information from other sources? You should be able to gather information from as many sources as possible, and don't just passively accept information as true because it sounds good. Do your research. It is everyone's responsibility to ask questions, evaluate data, and make informed decisions. I'm not saying that everybody needs to go out and become an expert on every single topic, but if you suddenly see some information popping up on Facebook about how, oh, there's a new COVID-19 vaccine and it's killing everyone and destroying the environment and killing all the birds. It's important to take this information very critically. So you should be gathering information from multiple sources. Is this just one fear-mongering article that was written by somebody who doesn't really know what they're talking about but just wants to create a stir? Or is this something that has been gathered from data from multiple sources that are all coming and drawing the same conclusions? Another thing you should be evaluating is how reliable is this information? What is the source of information? Is there a possibility that the research is biased? Who stands to gain if you were to accept this claim as true? If you decide that there is a new vaccine that has been created, but it's all kinds of horrible for you or for your health or for the environment, or has these long-term effects, who stands to gain if you decide that that is true, or if you decide that that is false? What are sort of the long-term ramifications of how you accept and interpret that data? Scientists publish their work in peer-reviewed journals. So another question you should ask yourself is, where is this information coming from? How reliable is this? Is this somebody's blog because they read a scientific article, or is it somebody's blog about a news article, about a scientific article? Where is this information coming from? Hardcore data, peer-reviewed data, data that has been backed up by multiple experiments, that has been backed up by many different researchers is going to be published in peer-reviewed journals, not blogs on the internet. Now, that's not to say that blogs on the internet aren't necessarily true, or that they are intentionally spreading misinformation, but just think critically about where this information is coming from. Where did you read it? And where was this information obtained scientifically? Did they rely on anecdotal evidence or scientific research? Were the results interpreted correctly? These are all questions you should be thinking about. Not all information found online is relevant. Not all information found online is accurate. Not all information online is even true. So you should remain skeptical. Evaluate the source of information. Figure out where this is coming from, who stands to gain from it, what their possible biases might be. I'm not saying that everything out there is false. I'm not saying that you shouldn't believe what you read. I'm just saying you should think critically about the sources of information that are being spread. So here is just a little table, a guideline on how to identify a reliable website if you're going to be obtaining information off the internet. So number one, who's the author? You should be able to, if you are reading scientific claims, you should know who is standing behind those claims. Does the website provide information about the author? If not, try figuring out who that author's name. Learn about their affiliations. Learn about their credentials. Are they a scientific researcher specifically for one branch of a pharmaceutical company that has suddenly come out with all of these amazing claims about their new pharmaceutical? You should know where this information is coming from. And not only who's the author, but who's the publisher. Is this coming from an educational resource, a government resource, a nonprofit organization, a commercial resource? Commercial resources have a tendency to be biased because they stand to gain financially from whatever it is that they are publishing. If they didn't stand to gain financially from what they're publishing, they wouldn't publish it. That's not good business sense. So just keep all of that in mind. What is the purpose of the website? Is there a report on a study by a reliable organization? Is the purpose to promote scholarship? Are we just trying to spread information, let people know what's out there? Are we trying to market a particular product or a new technology? Are we just trying to present our opinion? Just throw it out. Then there's nothing wrong with presenting an opinion. It's just know that that's what you are reading is not necessarily pure science or objective science, but you're reading maybe biased or a personal agenda. And where was this information posted? And when was this information posted? If this information was posted 5 years ago and it was just picked up yesterday by somebody on Facebook, it's not necessarily the most reliable information. So you should look, are there older or more recent websites that support or contradict the information presented in this website? Has it been proven false, or is it brand spanking new and isn't backed up by any previous claims? These are just all things to consider when you start reading scientific research on the internet. So that's it for this chapter. At the end of each chapter, I'm going to put a list of you should now be able to. It's just a list of objectives for this chapter. Of course, you should definitely read this at the end of the chapter, but it's also a good idea just out of habit to open up every single presentation before you start reading the textbook on your own. Start with the first slide of the presentation, which tells you which sections we're going to be covering, and then skip ahead to the end, to this last slide, which tells you not just what sections we're covering, but what your objectives are for this chapter. So before you move on to chapter 2, you should be able to list the characteristics of life. If you can do that, you're in a good place to be prepared for any homework assignments, quizzes, discussion groups, or anything that we may need to recall this information. So you should be able to list the characteristics of life, describe how evolutionary relationships are reflected in those modern systems of classification, define and give examples of the following groups of organism: population, community, ecosystem, biosphere. Define an experiment with a control and experimental group that, design an experiment with a control and experimental group that follows the scientific method. Your textbook does an excellent job of walking through an experimental design about whether or not oatmeal will lower blood cholesterol levels. Take a look at that. And then maybe give yourself a challenge. See if you can design an experiment with a control and an experimental group that's going to follow that scientific method. See if you can come up with a hypothesis, come up with a prediction, an experimental format, and then be something that you could draw your conclusions from. So this would be a great mental exercise to make sure that you have a strong grasp on experimental design and the scientific method. All right, and that's it for this chapter. Thank you so much for hanging in there, and I'll see you guys all again for chapter 2.